Hi, my name is Alon Marx from IBM Cloud Storage Solutions. With me is Oshrit from IBM Research, and we'll be talking about enabling near-zero disaster recovery with hybrid clouds. So we'll start with a definition of disaster recovery. Basically, we see here the definition: process, policies, and procedures for recovery of technology infrastructure after a natural or human-induced disaster. What it actually means is having a site and getting it back to life after a disaster in another place. As you can probably understand, this is a complex operation involving server, storage, networking, software, and configuration. And I want to start with a little some definitions again. Two ways to measure disaster recovery. The first one is recovery point objective, RPO. RPO basically describes the amount of work that is being lost in case of a disaster. And there are several levels. Backup and restore will take you weeks or days to recover, or to lose, sorry. And replication can take hours, minutes, seconds, or in the synchronous replication, this is nothing. There's no loss at all. The second way of measuring is recovery time objective, RTO. And RTO is basically how long it takes to get things working again. And again, we have a few levels. An active site is practically seconds or minutes. If you have a hot site, you need to ignite everything, and it takes maybe hours, maybe even days. And if you need to buy equipment, well, good luck. So again, just to summarize this, we have the RPO, which describes the amount of data that is lost. And we have the RTO, which describes the time it takes to get things working again. So basically, what are our project goals and milestones? What we did is basically a project that handles disaster recovery between OpenStack clouds. We had here two phases. The first one using backup and restore. That's the more basic option, and this is working today, and actually it is shipping today with IBM Cloud Manager, and it's included in the European FP7 Orbit research project. You can see here on the map two sites with a distance of 260 kilometers. And the second phase is actually using real-time replication. And this is done as a proof of concept. This is not used anywhere at this stage. I want to talk about a few use cases. So first of all, we just saw a use case of two physical clouds. But there are additional use cases. A common use case today is to have a physical cloud and somewhere a DR site that is on a public cloud. That's the upper option. And there are even cases where you have a site, an OpenStack deployment on the cloud, and another deployment that is serving as a DR site that is also on the same cloud, the same public cloud, or maybe another public cloud. And the more interesting use case is what we call bursting. Now, I want to say up front, this is not exactly DR, and you'll see what I mean. Let's say you have an application working or several applications working, and you know there's a big event ahead of you. You know things will work slowly or even crash. So instead of breaking down, what you do is you prepare another site that will serve as a load balancing for load balancing. What will happen when you have your disaster, which means a lot of work? You just offload to another site, and then you have, instead of two applications in this example running on the same site, you will have one application at each site, and then you can continue to work normally. Handing it off.
Okay, so I want to discuss more our disaster recovery approach and present some concepts of the work we did. So we look at workload at the cloud, and our objective is to seamlessly transition a workload from a primary cloud to a secondary cloud. And to do so, we basically look at two things. The metadata, which is a description of the workload, list of servers, list of volumes attached, network configuration, SSH keys, all those data, and the data, which is volume data, images data, and we need the metadata to recreate the workload, and we need the data to actually start the workload from where we stopped, from the same state. So we introduced a disaster recovery project. It's running as an OpenStack service, and it orchestrates, protect, and recover. So we realized that different workload requires different disaster recovery policies. Some servers are stateless and can be recovered from images. Some can be recovered from point in time, from a snapshot, and some actually require consistent data replicated. So to support different policies, we design it as a pluggable architecture, and we have various drivers implementing the protect and recover API. We also take into consideration that when disaster strikes, we might no longer have the primary cloud. And so we store all the data and metadata in a safe. For example, a Swift a container that is accessible from both of the clouds. Okay, so our backup and restored approach was already introduced and presented in a live demo in Paris summit, so I'll go over it briefly. Our primary cloud now runs also the disaster recovery service, and what we do is we select the workload we want to protect, and we attach the resources in the workload, the policy. So in the case of a backup restore, we attach we define the servers with server backup driver and the volumes with volume backup driver. And on protect, we collect all the metadata and data and put it into Swift. So the Swift is located on a third side to provide you desperation in case of a disaster, and to be able to recreate the workload, we use it and since not all application might have defined the hit template, what we do is we actually create it on the fly during protect, and we store it on Swift in the container as well with all the metadata and data. And in backup and restore, at this stage, we might not have the recovery site up and running. So all is in Swift, and when disaster strikes and a secondary cloud is brought up, is running the disaster recovery service too, it pulls all the information from the safe. It reads the driver, the policies used, it loaded them and run them to restore the data on the secondary, and then run the template after it made some template adjustment to the new resources to recreate the workload. Okay, and to enable near zero runtime recovery, we use data replication. So here we have a storage system that supports replication on both sides. Both sides are active and running. And we have a replication driver that actually takes care of the metadata. So let's see how it looks like, how the flow looks like. So the user defines the workload to protect and how to protect them. Then it invoke protect. In the protect stage, the driver backs up the metadata to Swift, and then it activates memory on the replication. Now there is an automated system that knows when a disaster occurred, or in the worst case, a user that invokes the protect scenario. And again, the disaster recovery service reads the metadata from Swift, loads the replication driver calls the promote on the storage system. That changes the role of the backup to master and stops mirroring. Now, since all the data is here, we use the template that we generated to recreate the workload and get it up and running again. We are looking for collaborations to take it to the next step. So if you are working on disaster recovery or interested in disaster recovery, let's discuss.
Thank you.